when 2.56 gram of sulfur was dissolved in 100 gram of CH2. The freezing point is lowered by 0.383 Kelvin. Calculate the formula of the sulfur. They had given the Kf value for CH2 as 3.83 and the atomic mass of sulfur. So what they are asking in the question first, formula for sulfur. Yes, X. So formula for sulfur they are asking. What they had given first, the depression freezing point. The freezing point is, excuse me, the freezing point is lowered by, in the sense del TF, that is equal to 0.383 Kelvin they had given. 0.383 Kelvin they had given. Right. And then here, Kf value they had given. That is 3.83 Kelvin per kilogram per mole they had given. Right. So since it is involved the depression of freezing point, we can go to the formula. Del TF is equal to IKF into M. Right. There is no place for I here, so we can write KF into M. So this can be written as KF into what is M? Molality. So what is molality? Molality is equal to number of moles of solute. Number of moles of solute by mass of solvent. Mass of solvent in kg. Right? So what is number of moles? Number of moles is equal to mass by molar mass. Right? So we can write as molality, that is equal to number of moles of solute. Solute is always 2 or W. So that is mass by molar mass, WB or W2 by MB or what is that? M2 divided by molar mass of solvent in kg. Solvent is 1 actually, 1 or A. So that is mass of solvent in kg. Kg means we have to convert into grams, you have to divide by 1000. Right? So this can be written as WB, 1000 will go upside, into 1000 by MB into WA. So remember, A denotes the solvent, B denotes the solute. Got it. So we'll write this formula here. Instead of M here, we're writing the formula Kf into WB into 1000 by MB into WA. So we are going to substitute the things what we are having in our hand. What are the values we are having? We are going to substitute. We have the del TF value. Let us substitute. 0.383. That is equal to, we have KF value 3.83. Right? And into what is the value of WB? That is the mass of solute. 2.5 grams of sulfur, right? This is solute and this is solvent. Minimum amount is solute, maximum amount is solvent, right? 2.56. So 2.56 into 1000 divided by molar mass of solute. Solute is sulfur here. Molar mass only we can calculate if we know this formula. So we don't know the molar mass. So let us write the MB as it is. Right, into what is that? Mass of solvent. So mass of solvent 100 grams. So 100 grams. Right. So this is what we got. So we have to solve this simplification. Right. So finally, if we solve this one, we can get the value. The value of this one, that is MB, will be equal to 256 gram per mole. 256 gram per mole. Got it? So we got the value of MB as 256 gram per mole. Now So what do you get? The molar mass of solute is 256 gram per mole. So what we have to calculate? We have to calculate the formula of sulfur, right? So what we have to understand, this molar mass, that is equal to number of atoms into atomic mass, right? Number of atoms into atomic mass. Got it? Atomic mass of sulfur is given in the question itself, it is 32. So we know the value of molar mass. So we can write 256, that is equal to N into atomic mass of sulfur 32. N is equal to 256 divided by 32, that is equal to 8. N is equal to 8, that is the number of moles is equal to 8. So the formula will be S8. Is it clear? So the formula will be S8. So this is the first part of this question. We will continue with the second part. Let us move to the second part of the question. This one. The blood cells are isotonic with 0.9% sodium chloride solution. Isotonic in the sense same concentration. Same concentration. Isotonic in the same concentration. What happens if we place the blood cells in solution containing 1.2? So actually isotonic means same concentration in the sense. So it should be 0.9 percentage. So we are placing in two places. That is, one is 1.2 percentage of sodium chloride and another one is 0.4 percentage of sodium chloride. So here, what is it? The concentration goes higher. In this case, the concentration goes higher. In this case, the concentration goes lower. So what happens? If the concentration is higher, now let us consider the blood cells like this. It is 0.9 percentage. And let us have the atmosphere like this. That is the surrounding. That is 1.2 percentage. So what happens here? The water particle, as per osmosis, the water particle move from lower concentration to higher concentration. So what happens that, so this is higher concentration, this is lower concentration. So the solvent particles move from here to here. What happens then? The size shrinks. Got it? The size shrinks here. In this case, what happens? The size shrinks. Got it? The same thing. So this is 0.9 percentage and here the atmosphere is 0.4 percentage. Here now, this is the higher concentration, this is lower concentration. So what happened? The solvent particles will move from lower concentration to higher concentration as per osmosis. The solvent particles, right? So here, the water from here will move from outside to inside. So what happened? The size swells, the size increases, the size swells. So in second case, it swells. In the first case, it shrinks. Is it clear?